This lesson goes over graphing quadratics. And we graphed quadratics before, but this time we have a little bit tougher problem because we have, in this case, three terms in the quadratic and that we have to deal with. And so what we really want to find is this axis of symmetry and vertex. And so you have to remember that the axis of symmetry, we end up needing this formula, negative b over 2a. And all this does is it gives us the x component of the vertex. The vertex, we just have to substitute that x component into the equation and then find the y value. And that's going to really help us out. From there, we're going to end up using what I call a parent graph. And a parent graph is basically the general shape of the quadratic. And the parent graph comes from just this portion here, this y equals x squared. So it eliminates all of this extra stuff, this 4x minus 4. This 4x minus 4, all that does is it moves the vertex into a certain location. The x squared is what gives it its shape, and so we'll talk about how that works. And so after we see a few of these, you'll be able to get the understanding about what an x squared looks like and what a y equals 2x squared, or in this case it'll become a negative 2x squared, ends up looking like. So let's take a look at the first part. First, got to find the axis of symmetry. So our b term is 4, but we don't want 4, we want the opposite of b. So here's b is 4, so it's the opposite of 4 over 2 times the a term. Well, the a term is 1 in this case, so 2 times 1. So that makes negative 4 over 2, which just makes negative 2. So that is the axis of symmetry. So what we're going to end up seeing is a graph that is going to end up having this line that can cut this parabola into 2 equal slices right along that blue line that I just drew. I also know the shape of this line because it's a positive x squared, so I know it's going to end up opening up. Well, we'll get to that in just a minute. Let's get to the vertex now. We substitute negative 2 in for these x's. Now, be careful here. It's negative 2 squared, and then it's a plus 4 times by negative 2, and then minus 4. So whenever you're finding the vertex, you're going to see this concept here where we go ahead and do this work. Notice how you have a negative 4 plus, actually a positive 4 because the two negatives will cancel out, positive 4 plus negative 8. So notice how one of these numbers is negative, but their one's double the other. And so then we got to take away the 4. So here we end up with a negative 4, and then take away 4 ends up giving me negative 8. So there's the y value. That's the y component of this vertex. So the vertex ends up being negative 2 comma negative 8. So I can go down and plot that point over 2 down 8 spaces. Put the dot right there and then use the parent graph to graph the rest of it. So one thing you can end up noticing is that we've got this minus 4 here. This minus 4, if you cover up the x values, that minus 4 represents the y-intercept. And so that can also help you graph this. So if you go over to minus 4, just on the y-axis, there's a point. Well, there's also a point opposite this axis of symmetry right on the other side. So it's 2 spaces to the axis of symmetry, so 2 spaces over here. But from there, I'm going to end up using this parent graph to get the rest of the points that I want. So what we can do is we can plug in a couple values for x. And notice that when you plug in 1 and you square it, you get the same answer for y as if you plugged in negative 1 and you square it. You get a positive 1. So each time, if you go in the x direction from the vertex, so I'm going from the vertex here. So let me go ahead and change the color. If I go from the vertex over one space to the right or to the left, so this is to the right or to the left, I'm going to go in the y direction one space. So if I go over to the right, I'm going to go up to the right. So over to the left, I'm going to go up. And then I've got a couple more points. And if you actually plug in 2 and you square it, you end up with 4. If you plug in negative 2 and you square it, you end up with, again, a 4. And that's why this always opens up. And so if I go ahead and go over 2 spaces, again, going to the vertex, not to these other 2 points. It's not the slope that we're dealing with here. This just gives us points. This is called a parent graph. This shape is for all y equal x squareds. So again, if you go over to the parent graph, or go over to this vertex, over 2 to the right, you're going to end up going up 4. 1, 2, 3, 4. So you'd end up right where we had a point before, at the y-intercept. Over 2 to the left, up 4. We could even go up more. Let's say we go over 3 spaces and we square it. We end up with 9. If you go negative 3 spaces from the vertex, you square it. You get positive 9 again. So if you go from the vertex over 3 spaces, you can end up going up 9 spaces. So we'd have another point there, and then one right on the opposite side of this axis of symmetry. So notice these graphs are symmetrical. So once you find 3 points, you've kind of figured out the rest of the graph as long as you have that vertex. And that'll help you graph those. And so you'll notice that every time for y equal x squareds, they're going to all look the same. The only difference is that vertex is going to be in a different spot. So we'll see that with this one here. Before we can find the axis of symmetry, we need to get y by itself. So first thing I'm going to do is move some terms over. I'm going to subtract this 2x squared from both sides. I need to add the 4x to both sides, so plus the 4x. And then I need to add this 6 to both sides, so plus the 6. So that's my new equation. It's y equals negative 2x squared, and then a plus 4x, and then a plus 6. So now I can use that axis of symmetry formula. Remember, it goes negative b, so the opposite of 4, over 2a, so 2 times by negative 2. So here I end up with a negative 4 over negative 4, which makes 1. So 1 is the axis of symmetry. So on the on the graph here, if I draw a line straight down here along 1, for x equals 1, that line will cut this parabola into 2 equal pieces. So from there, I need to find the vertex. Substitute 1 into x and find y. So remember, it's negative 2 times by 1 squared. So you got to square 1 first, then plus 4 times by 1, then plus 6. So go ahead and do the work here. We end up with a negative 2 times by 1 plus 4 plus 6. So that makes negative 2 plus 4 plus 6. And 4 plus 6, I guess I could do that. That makes 10. So this makes 8. So we have 1, 8. That's the vertex. So on that graph, we're going to go over 1 to the right and up 8 spaces. 1, 2, 3, 4, all the way to 8. All right, so we know this graph ends up opening down because it's a negative 2x squared. So this is what we call the parent graph. So the parent graph helps us graph it. Now, if you don't remember the parent graph, you can always come up with one more point. And that point here is 6. It's the y-intercept. So if you go to 6 on the y-axis, there's a point there. There's going to be another point just opposite. And that, you could have a general idea. You know it opens down. So if the parent graph gives you a couple more points to get a better representation of the line. So here, remember, the parent graph is going to be y equals negative 2x squared. So all y equal negative 2x squareds will look the same. This 4x and the positive 6, they just move the vertex to this spot right here. And then from there, it's all going to look the same. So let's go ahead and substitute some numbers in there. Let's try 1. If you plug in 1 or negative 1, doesn't matter. Either one is going to give you the same answer. 1 squared, negative 1 squared, still going to equal 1. 1 times by negative 2 means you're going to end up going down 2. So you can see how we got those 2 points right here by if you go over 1 to the right or over 1 to the left, you're going to end up going down 2, right where we thought. Well, it works again for other numbers as well. Let's try plus or minus 2. If you square 2 or square negative 2, you still get the same number, 4. 4 times by negative 2 makes negative 8. So if you go over 2 from the vertex again, from the vertex you go over 2, 1, 2, you go down 8 spaces. So we've got a point right there, and then a point directly opposite of it right here. You see, over 2 to the right, down 8, puts you there. And then from there, we've got nice 5 points. We can draw our parabola. So all y equal negative 2x squareds are all going to look exactly the same as that, opening down just like that one there. So we'll go over some more examples in part 2, so check that answer out.